Good day, everyone, and thank you for joining us for our technical demo around Materialize, the operational data warehouse. Today, you will hear from our head of product, Jessica Laughlin, and one of our senior field engineers, Josh Ehrenberg. All of them introduce themselves in a moment. After the demo session has completed, you will receive a recording of the session that you can share along or review again. And we are doing a couple more technical demos both next month and the month after. So if you go to the same registration page that you found for this one, you can register or send it to teammates that you may want to as well. If you have any questions, feel free to put them in the question or the chat. And should we have time at the end of the session, we will address them. And with that being said, and without further ado, I will introduce Jessica Laughlin, our head of product, who will give you a quick introduction on Materialize before we jump into the technical demo. Jessica, take it away.
Thank you, Brian. So as Brian mentioned, I'm Jessica. I am currently our head of product here at Materialize. I've actually been at Materialize for a while. So I joined 4 years ago. I was on our engineering team. So super excited to talk to you all about Materialize, the operational data warehouse, what it is, why you might want one, and also very excited to be here with Josh. So let's kick it off. I think a good way to motivate the operational data warehouse is to think about the data itself. And a way that you can cut this data into two buckets is analytical data versus operational data. So your analytical data is probably something that all of you are pretty familiar and already working with. It's that data that your business is generating and collecting every minute, every day since it was founded, and it is just accumulating and growing. So you have click streams, purchase orders, IoT data, really any data that powers your business, and it's enormous. It's huge, and in order to work with it, you put it into an analytical data warehouse because those tools are perfect for crunching over terabytes and petabytes of data and giving you information about it. So when you want to understand how your business has performed in the past, whether it's the past week, the past month, I don't know, the last 5 years, that's the correct tool for you. But as people have gotten more interactive access to more data, they've been pushing the bounds of what an analytical data warehouse was actually built for. So they've been wanting to power use cases and dashboards and emails and triggers off of data that is actually more recent. So instead of thinking about the last week, month, year, they want to power things off of data that's happening today, within the last 24 hours, within the last hour, maybe even within the last minute. And the problem is that analytical data warehouses weren't built for this. They are built for looking way back over enormous amounts of data, but they're not built to automatically respond to changing data. They're built for human-in-the-loop interactions. So you want to run these big queries, you want to build dashboards, and from this, you want a human to make a decision about what to do next. What we really want from operational data is to automate that decision-making, to use the context we have and the new information that we have to send an email, trigger an alert, say that some spend is fraud, stop a factory line. We want to do these actions within seconds, and we can't have a human in the loop here. So we need a purpose-built tool for these types of use cases. Until today, or until recently, there hasn't really been one. So people have been using two different types of tools to solve this problem. And I've talked a little bit about how people use traditional cloud data warehouses, so your Snowflakes, your BigQueries, your Databricks, to solve this problem. And really what you're going to do is micro batch. So you're going to try to get fresher data by running your queries more often. Instead of running it every hour, you'll push it to every half hour, to every 10 minutes. But the trade-off here is cost, because these tools weren't built to keep your data fresh and up to date. They were built with an entirely different purpose in mind. Another approach to serving these operational workloads today is with a stream processor. So something like a Flink, for instance. Stream processors will give you really low latency results. They give you incredible tools to build very detailed pipelines, But the problem is that they require highly specialized skill sets. And so you have to staff up an entire team. You might be slower to produce or change your data products. And so these are two approaches to dealing with operational data that we see in the world today. And we are pretty unsatisfied with both of them. We think that you should have a tool where you can use SQL to act on your freshest data, like a cloud data warehouse, because that enables your data engineers, your data analysts to build operational workloads. But we also believe that you should have the benefits of the stream processor without the drawbacks. So that is part of why we built Materialize. And we think that when you choose an operational tool, so something to build on top of your operational data, you should require at least 3 things from it. I'm going to touch on these here today. We touch on these a bit more in our blog post about our product principles written by our co-founder, Frank McSherry, so I'd recommend taking a peek at that if you have time. But those 3 tenets are responsiveness, freshness, and consistency. So responsiveness talks about the interactive access to your data when you run a query or when you issue a command against your data warehouse. How interactive is it? How quick is it? Does it have to spin up a pipeline in the background? Do you have to wait for a few hours to get a response? We believe that you need interactive access to your operational data to build operational use cases. Similarly with freshness, how quickly does your new input data turn into newly generated results? Does it wait for a batch process to happen? Is it in a 30-minute or an hour-long lag? Or is it immediately computed into a new result? We think it should be immediately recomputed. And the last bit here is consistency. If you're going to take the human out of the loop, your data has to be right. And you have to be convinced and confident that you are acting on the right data, the correct data at any point in time. We think this is non-negotiable for an operational tool. If you want responsiveness and freshness, but you don't care about consistency, you can work with a microservice or cache. That probably serves your use case. If you care about freshness and consistency, but not responsiveness, you can work with a stream processor, like I mentioned before. And if you care about responsiveness and consistency, but you're okay with some staleness, you don't need freshness, you're okay with an analytical data warehouse. But in a world where you're acting on operational data, we think that you need all 3. You need an operational data warehouse, and Materialize can serve that need in your organization. To give a bit more context, this is how we think about Materialize fitting into your data stack. So we ingest from all your upstream data tools, your relational databases, your generated SAS data, your movement tools, and we sit in front of the analytical data warehouse so that you can run operational queries, you can build genuine real-time applications, and you can push that data back out to SAS tools as needed. After you handle the operational use cases, that's when you send that data to your analytical data warehouse to think about over time, over weeks, over months, over years. But Materialize is the moment where you can act on it in an instant and be confident that you're acting on the correct data. And we look a little bit similar to analytical data warehouses you might be working with already. We separate compute from storage, we have a SQL control plane, but the real difference is that we're working with streaming inputs and streaming outputs. So we're not batch-based, we are interactive, fresh data. And the secret powering Materialize is that we do incremental computation of your data. So where traditional databases and data warehouses, you write to a table and on read, you crunch that data and give yourself an updated result. And there are ways to work around that with Materialize views. Materialize flips this on its head. So as your input data changes, we automatically update the results that you want to keep fresh via your indexes and your Materialize views. So on read, you do not do any work. Just to recap why we care about this, using an operational data warehouse, so something that automatically updates your results as your input changes, unlocks your freshest data to be acted upon. So you can build warehouse native apps that are actually acting on data the second it changes, or the millisecond. So because we're a data warehouse, we work with lots of different verticals, but a few use cases we're powering today are fraud detection. where fraud, when it happens quickly, and it is equally important to catch it quickly. So if you can keep your models up to date within a second, you are likely to shut that down faster and save more money than if you're running it in 30-minute batches. We have examples of customer segmentation, reverse ETL, security automation, other things on our website, things we'd be happy to chat about. But today, I'm going to hand it over to Josh to run through a demo of how you do some real-time store sales and alerting with Materialize.
So we're going to now see how it works in practice to keep your data, your operational data fresh. So for today, you know, we've talked a lot over time about how well Materialize scales up horizontally to really big workloads and complex architectures. But one thing that gets missed sometimes is that it also scales down really well. So that's what we want to talk about today. I want to show you how efficient and easy Materialize can be for smaller businesses or businesses with only a targeted need for real-time data. So our goal today will be a full end-to-end deployment of Materialize in around 20 minutes. So there are tons of examples of situations where an organization doesn't need a lot in real time, but maybe just have a few things that would be really useful to be able to keep fresh. Maybe an analytic they'd like to use as a source of alerting or a source of automation. And so that's what we're going to look at. For today's example, we're going to imagine that we're managing a chain of 3 retail stores. And our use case is going to be as follows. We found that it would be very impactful to be able to compare our incoming revenue over the course of the day, right, versus an average of the last 2 weeks of revenue. This is going to allow us to see how we're trending compared to the average over the course of the day and respond immediately if something is going badly at one of our stores. And we're going to achieve this with 2 SQL queries and a simple dashboard visualization. In addition, we would also like to implement an alert if one of our stores stops booking revenue for more than 15 seconds. Since it would indicate something going wrong at that store, and we'd want to be alerted about it, even if we didn't happen to be looking at our dashboard at the time. So that's what we're going to look at today. The slide that Brian has up here are going to be the steps that we're going to take to implement that over Postgres and Materialize. And, you know, to create a pipeline of changes that we can incrementally compute analytics on and build, you know, further event-driven services and real-time visualizations downstream. And it's this ability to accurately maintain these analytics each time the data in our database changes that's the core of the value provided by Materialize and enabled by our timely data flow internals. All right. So I'm going to share my screen now. You should see infinity. Okay, we're only going to do one step from a command line today, and that is just to enable our Postgres database to replicate data to Materialize. So in order to do that, here, we're going to, let's go back to our very first, okay. We're using 2 tables today. So I've issued 2 commands here just to turn on full replication for our sales and store table. That's going to allow the transaction log to get all the data we need for replication. And then the next step here is to create a publication. Publication is just going to be how we refer to this replication. We're going to call it Materialize, and that's going to be what Materialize connects to for the replication of the sales and the store tables. And that's it. We're done. We have enabled this Postgres database to share data with Materialize. All the rest of our steps today are going to be from the Materialize console and from Grafana. So let's take a look at the console next. Now, as it turns out, there's a bunch of exciting new functionality in here. that we're going to be able to make use of today. The very first thing we're going to do is create a connection. A Materialize connection just defines how Materialize can connect to our data sources. And right now, the two biggest data sources in Materialize are Postgres and Kafka. Obviously, for our demo today, we're using Postgres because that's where our transactions are. And we support direct change data capture from Postgres, so we don't need any other infrastructure just beyond our Postgres database and Materialize. So we'll create a new connection of type Postgres. We'll just call it Postgres connection. And schema just refers to where in the Materialize object schema this is going to go. So we can create as many schemas as we want. I've created one called Postgres, and we'll put our connection information there. The host name is just the host name as it came from. This is from RDS, from AWS. So we'll just put the host name in here. Our database, as we saw earlier, is called Materialize, and standard Postgres port 5432. The user, we're going to use the standard Postgres user. You'd probably want to create a dedicated user for Materialize in the real world, but we'll just use the standard one. You can save passwords in Materialize securely. So I've already saved my password for the Postgres user, but if you need to stick a secure password in here, you do it right here. And then we're going to require SSL for this connection. And I'm going to click here on create connection, and that's done. So we haven't actually made a connection to the database yet. All we've done is informed Materialize how to connect. So in order to create a data source, we're going to create a source, a Materialize source, which is where we tell Materialize which tables to capture from our upstream database and designate some Materialize resources to perform the continual task of pulling in data every time there's a change to one of those tables. So now I'm going to create a source here. It's already pre-populated the Postgres connection that we just created, and we'll call this Postgres source. Again, we'll put it in our Postgres schema in our data model here. And here, this is a cluster. So this is the concept, much like a warehouse in Snowflake or something like that. This is where our compute resources live. They come in t-shirt sizes. Today, we're using a 3x small, which is the smallest clusters offered by Materialize. They represent fractional CPUs. So, like we said, scaling down very effectively. Obviously, you wouldn't be able to do this if you're standing up your own infrastructure. Publication, this is what we created in the first step. We called our publication Materialize. And now we'll just, which tables out of the publication do we want? We're taking sales, and we're taking store. So now I'm going to click on create source here, and you can see already, okay, so that has created, and in the background here, it's starting up that cluster, and now you see it's running. It is already pulling all the data from those tables into Materialize, and we'll start keeping up to date with any changes made in that database. So all our connectivity is done. If this was a big enterprise deployment, we would probably be using, security features like Bastion hosts or AWS Private Link, and we have all of those options. We can do these steps with Terraform, all the things to make it battle hardened and all. But today our fictional company today is a small company. We're doing things from the console. It's just us. So we're up and running here. We're getting data. Okay, so we've created our sources, and we can see in the console that they've come up cleanly. It's pulling in our data. The next thing we're going to do is actually write our analytics. And now for that, we're going to use the new SQL shell in Materialize. Actually, in the background, our built-in SQL shell is just a Postgres client. Okay, so you don't have to use our SQL shell. You can use pSQL or whatever your favorite database client is. As long as it can talk to Postgres, it can almost always talk to Materialize. And now we're going to connect to our cluster. So the next step is, since we're using the Postgres schema. I'm going to set our cluster to compute and our schema to Postgres for this session. That's done. Now we are, for the rest of this session, talking to that schema and cluster. And let's build our first analytic. Here's what that's going to look like. Oops. This one's called Today's Sales. This is going to be the query for graphing the sales from today. So as you can see, we've got an inner CTE here that's going against our sales table, extracting the store ID, the hour, the minute, and the sum of the cost, which is going to be revenue. And we have a group by over the store ID, hour, and minute. So basically, we're summing up all the data by minute here. And you can see there's a time filter that's going to select for today's date. So that means we have a 1-day window, and that will flip at minute every day. Because these these queries run continuously, right? So we're constantly evaluating that time window, and it will, as soon as the day flips, this will automatically flip, right? The outer query here, it's what we are doing is joining our CTE to itself. We are doing that so that we can do a cumulative sum, right? We want each 1 minute data point to be the sum of the previous minute and that minute, so that we can see sort of an increasing line over the course of the day as our daily revenue accumulates, right? So we're joining it to itself, and that's worth calling out because I think joins are really one of Materialize's superpowers. Very tricky to do well in a lot of streaming frameworks. It's a hard problem. Timely data flow ensures that our joins are not only easy to do, but consistent, because there is a timestamp associated with each data point. We can ensure that our joins are consistent. In fact, we support strict serializability. This means that you can safely write these queries for financial transactions and be sure that you're never going to create a data point that's inconsistent at any point in time. It will always be consistent with the most up-to-date available information. So that's what we're doing here. We're joining it to itself. We're grouping by the store ID, the hour, and the minute to create our data points. And that's done. We've created our view. Now, in Materialize, all we've done is put this SQL into our schema, into our objects, under this name, under Today's Sales. It's not actually running this yet. So what we want to tell Materialize next is, that view that we just created, we would like that view to run continuously and maintain data each time it changes. And to do that, we need an index. And what an index tells Materialize is simply that. We're going to run this view continuously on a cluster, incrementally update it, and it's going to index that data on these 3 fields, on store ID, hour, minute. That means that if we query now Materialize, and let's do that. Our index is created, as easy as that. Now, if we perform a query on this view with these 3 fields in the where clause, it's a point lookup against this index, and it's going to return in milliseconds. So that's important to realize, and this data is now being maintained. All right, so that's today's data done. Now we need our weekly average. This query looks very much the same. The only difference is we're dealing with multiple days now, so we're extracting the date as well as the hour and minute. And we've got here now a 14-day window, right? And then outside of that, we have another CTE, which is again doing the self-join so that we can get our cumulative data. So this is creating 14 days worth of cumulative data points. And then in our last CTE, we're just averaging by day. So what we really want is 1 day's worth of data points that are an average of each of those. So because we're going to be comparing today's data to the average of the last 14 days. So we're going to average on the outer CTE here. And that's done. That view is created. And just like before, we'll create an index on store ID, hour, and minute. And now that is being maintained as well in Materialize. Okay, so we're almost done here. This last one is just for our own convenience in building the graph. I'm going to build a combined view here that just joins these two indexes or these two views that we just created. We're going to join on the store ID hour and minute to make these easy to graph against each other. And that's done. And of course, just like before, we're going to create an index. This time, we're just going to index on store ID, right? Because here you see we're using, these are the three fields that we built our previous indexes on. So you get point lookups here. And again, when we look this up from our graph, we're going to look it up by store ID. So that's what we'll index on. And now that's running. We're done building our queries for now. So for the next step, I just want to move over to Grafana, and we're going to build our dashboard. I'm just using Grafana Cloud because it's easy, but you can use any Grafana for this. We're going to create a new dashboard and add a visualization to it. You can see here I've pre-created my connection, but one thing you'll notice is this is a standard Postgres connection. This is a theme with Materialize. Since we're Postgres wire compatible and we use Postgres query syntax, you know, one of the most common integrations out there in the world. Lots and lots of tools can speak Postgres. This is no exception. And lots of times we can just, any tool that can talk to Postgres can oftentimes talk to Materialize. And so that's what we're doing here. We're going to use this connection. If I was going to create that connection, I could just come here to this external tools. Here's all the stuff that populates that connection, right? So now let's create a data panel. We'll just go straight to code here. Here's what my query is going to look like. You'll see how simple this is. I'm just creating a Grafana style timestamp here, and then pulling my two fields, my average cumulative revenue and today's cumulative revenue from the combined view. And this graph is going to be for store ID 1. So you remember how I said we were going to look up by store ID? Here's the where clause for the store ID, and that's what we've indexed on. So this will be very performant. And we'll call our view store 1. We'll apply this and make it nice and big here, refresh, and bang, just like that. Here's store 1. And for the rest of our visualization, what am I'm going to come here, duplicate this, and we'll edit it and make this graph for store 2. Apply, and then here, duplicate, edit, store 3. All right, let's refresh all of this. And as promised, here's our 3 graphs in a visualization. And now we're looking at 6 hours here. I could zoom in on the last 15 minutes here. You can see this is right up to the minute here. We're getting data points. And one thing, you know, immediately we're getting some signal here about how our stores are doing. We can see store 1 is doing the worst today. It's got there's a meaningful gap between the average revenue and today's revenue. It looks like store 2 is doing a little bit better at some points, although it's now looking pretty much like store 1. And then store 3 is crushing it today, coming in way above the average. So if I'm managing my chain of stores here now, I've got a very good up to the minute idea of what my stores are doing. And by the way, we've set this all up in 20 minutes, and we're doing it on a fraction of a CPU on the Materialize side. So no additional infrastructure for you to spin up, no operations, nothing like that. So, but we did promise one more thing. We promised that we're going to do an alert if the revenue stops flowing. So let's do that next. In order to do that, we'll go back to the console here, to our SQL shell, right? And we'll make sure we're in our Postgres, not cluster, in our Postgres schema. Okay, and now we're going to create one more very simple query. This is just a view of all of the sales transactions in the last 15 seconds. All this is saying is get everything out of the sales table that was created in the last 15 seconds. And just like before, we'll create an index on that by store ID, right? And now that's being maintained by Materialize. So I can now query just the transactions by store in the last 15 seconds. But in order to create an alert on this, we're going to, whatever we're using for our alert service downstream that's going to handle our paging or our Slack messages or whatever, can create a long-lived Postgres connection to Materialize to get this information. And we call this a subscribe. So here's the syntax for that. Basically, we're just saying subscribe to this select query. And the select query is count the number of sales transactions from the 15-second view where, remember, we indexed by store ID. So this is the alert for store 1. Let's take a look at it. This now, you'll notice this is changing. This is telling us how many transactions we've seen in the last 15 seconds. And we're seeing that number going up and down based on what the query is returning, but you can see this is happening in real time. And if I was gonna, I could just tell my alerting system, hey, if this count ever goes down to 0, that's an alert. So let's make that happen. Let's break something here. I'm going to go here to, this is my service that's generating the data into my Postgres database, and I'm just gonna stop that. And if we flip back here, we'll watch our count go down for the last 15 seconds. And just like that, our count hits 0. And now we're in an alert condition. Now we can be paging people out and saying something is down at store 1. And assuming that gets fixed and we start generating transactions again, immediately we'll see this subscription start to reflect the fact that there is data in the last 15-second window. And so with that, that concludes my demo for today. We've shown how in only a few minutes, we've gone from a standard Postgres transactional database to having streaming, real-time visualizations and alerting on our key operational metrics using Materialize and fractional amount of compute. So, a very economical way to expose just these key operational metrics.
But thanks everybody for your time. Be on the lookout for a recording of this if you want to share it. If you have any questions, feel free to reach out to the team via the website. If you want to try a trial with some playground data or even bring your own data, go to the website. You can launch a free trial. And if you have any other questions, feel free to reach out. Have a great rest of your day, and I look forward to seeing you next time. Thank you.
Thanks.